Hello everyone, good morning all of you. I hope all you are doing well. Myself Yagnik Patel and I am an application engineer for SolidWorks at Engineering Technique company. So as we all know, today our session is related to the SolidWorks inspection. So our session will be last for 45 minutes to 1 hour and I would give you a demonstration about 30 minutes. So meanwhile, if you have any question during my demo, please write down in your note. So I would try to solve your questions at my best. So let me start with what is SolidWorks inspection first. So the SolidWorks inspection is a kind of add-in and the separate standalone application that automates the ballooning of the engineering drawings and 3D files with the product and manufacturing information, and which is called a PMI. It also minimizes the time needed to record the inspection measurements. Also, the SolidWorks inspection streamlines the creation of industry standard inspection reports. So why it is required? The company quality departments are tasked with carrying out the quality inspection processes, and this often involves the creation of the documentations such as drawing with balloon callouts, report for during inspection, or additional deliverable required with the part. The manual creation of this inspection document will often take hours using Microsoft Excel, handwritten annotations, and with other methods. So basically, the SolidWorks inspection could be one of the good and useful tool for this kind of particular area, and it basically reduces the delivery time up to 90%, and also it automates the processes to collecting the data, and also the minimal time required for the training of this software. So how it works? SolidWorks inspection software automates the manual and tedious process by leveraging the existing 2D legacy data such as the SolidWorks file, PDFs, TIFFs, and so on. And also it captures the data using digital measuring instrument. So we can recognize basically the PDF files as well as the image files. So here I have mentioned a few of the industries vertical where it could be very useful. So this could be useful for the industrial equipment, medium and heavy machineries, also pharma machineries. Also it is very useful for the packing and packaging machineries, material handling equipments, turbo machineries, automobile industries with including the commercial and off-road vehicles. Also it could be very useful for the food and beverages, life science, and many more. So basically this software could be very useful to those industries where the qualitative production required. So who can basically use this software? So here I have mentioned few departments. So in this department they can use this kind of software specifically. So the design department, the quality control department, the production department, manufacturing department, as well as the documentation department could use this software. So here the SolidWorks inspection come with the two different packages. They are called standard and professional, and all of these packages comes with the add-in for the SolidWorks application. So here I have already mentioned few of the features available in two different packages. So in both packages we can create the inspection reports, we can recognize the character optically, also we can compare the PDFs, and we can generate the revisions for 2D and 3D by managing it. Also we can plan the quality samples. Also we can export, we can get the numbers of different export options such as the PDF, Word file, as well as e-drawings file, and so on. Also we can automatically balloon the characteristics. Also we can generate the customized inspection report by customizing the templates. Also we can manage the file in various ways. Also we can enter and import the measurement, and finally we can highlight the critical dimensions. So this all the features we can get within both these packages. What we can get more with the professional package? Here we can get the SolidWorks part assembly file support, also 2D and 3D CAD file support. Here also we can inspect the measurement. So we can check the status by checking the pass and fail status of the characteristics. So let's move further. So here I have mentioned the summary of our today's session. So in our today's session, I'm going to show you how we can collect the data from the project, how we can manipulate the characteristics, also how we can export the data in a different formats, and how we can generate the report by using customized templates. Also, I will show you how we can recognize the character optically in image files, and how we can manipulate those data and collect the desired results according to our requirement. And finally, I will show you how which kind of file support could be acceptable in this application, and how we can recognize those character which comes with a different kind of languages. So let's get started. So here I'm going to start with the project data collection. So let me take you to the SolidWorks window now. So here I have already opened a model of clamp in which you can see the all kind of dimensions and geometric tolerances, and not everything is available over here. So let me start with the new project over here. So here I'm going to choose a template which is empty template basically. So let me choose here the properties from the document. So here I'm going to add the description, the part number. So this kind of stuff we can choose from the customized property of the document. So let me choose here the document name, document number, same as the number of the part, and let me write down here revision. Let me assign here the vendor required. Basically we can also change the vendor, we can change, and also we can delete, and we can also edit it over here by choosing this tag. I will show you later in this session. Let me write down here the job number. If you want to add some property, we can add it over here. Also we can delete some properties directly from here as well. So here I want to see the characteristic start with the 1 number. Also I want to see it in the clockwise direction, and also I want to select here classification with the measure to all of those characteristics. If we want to change in the future, we can select the particular, and we can change the classification for those particular characteristics. So here rather I'm going to use automatic method. I'm going to extract the balloons manually. And as you are if you are a quality engineer, or if you are working in a quality department, you should have knowledge about the sampling. And if you don't have knowledge about this, you can just Google it simply, and you can get information about the sampling data. So just let me choose here 2.5 value. So in this case I'm going to extract manually, so let me just leave it like this, and this time I just want to choose this precision tolerance over here. So if I want to choose some specific characteristics directly over here, so let me just choose it over here. So it collects the data directly from the dimension. So if I am choosing this basic dimension, the software is very smart to understand what dimension is normal and what dimension is basic dimensions basically. So let me do the same thing for this reference dimension, and it recognizes itself. So this time I want to add this dimension, as well as I want to add here geometric tolerance. So also it can recognize the geometric tolerance as well. So this is one of the good method if you want to specifically get the result in a report about these characteristics. You can choose this method, and that's how also we can assign the balloons characteristics like this. But what if I want to get all kind of balloons for all kind of instances directly over here? So rather I'm going to use manual method. I would use here the automatic method. So let me again give this descriptions over here about these properties. Let me choose the revision again. The document name is same as the description, the document number same as the part number. So let me write down here the revision. Again let me write down is the same vendor, and here I'm going to write down the job number again. So the same thing I want to select here, and this time basically I want to change this extraction to automatic from the manual one. Also I want to balloon this automatically. So here again the same value I'm going to apply. So I want to select here 2.5. Let's move further. In this case I want to choose reference as basic dimensions only. Also we can include the all kind of stuff from here, such as node, GD&T, hole callouts, table, welds, as well as the surface finishes according to our requirement. Also we can give here the tolerances by precision and by range according to our requirement for the angular and linear dimensions. If I want to change over here, I can just give the values to them. So this basically it would be assigned to those characteristics in which the non-standard tolerance available. So that's how I can just recognize it over here, and I can get all kind of balloons required for the characteristics. So here as you can see this count has 2 times because there are 2 times hole over here. So the software can recognize it gives the shared balloon for 2 different instances over here, right? So that's how we can basically collect the data. So if I want to generate the template over here, so let me choose the same template as I have created, and just let me save it with some proper name. So let me save it with the ABC. And for the next time, if I want to collect this all the information by just selecting it, I can just simply select this template over here, and I can get all kind of information available or required for the report. And some information we should enter by our hand, because sometimes it is possible to change the vendor type or maybe job type, you know. So that's why we need to these values we should apply by manually. So let me again choose the same thing here, and the rest of the thing already applied by the template, and also the precision tolerance also already applied by the template like this. So as we have seen, the interface is very simple by using this application, and it is very easy to collect the data from the document. Also we can specifically select the characteristic for the report, and also we can easily assign the tolerances to the different characteristics, and also we can generate the customized data collection templates according to a requirement. So as we have collected the data from the document, now it's time to manipulate those data. So let's get back again to the SolidWorks. So here as you can see, the balloons are not attached with the dimensions. So let me just attach it like this. So in this, if I'm moving this balloons, it moves with the dimension. So that's how we cannot lose the path with it. So basically, if I want to change the shape of the balloons, I can change over here. If I want to add some prefix over here, if I want to change the feed type, also I want to change the shape of the balloon, I can change it like this. Also we have some separate window for the characteristic balloons. So also we can apply the shapes and the feeds and prefix according to our requirement. Also we can set the offset of the balloons from the dimensions by adding some XY coordination values. So just let me hit OK. So that's how we can get the different shape of balloons like this. So now let me just unattach these balloons with the dimensions. So as I mentioned before, this 3 number of characteristics has 2 different values of the characteristic, right? So if I want to group it in a different way, so I can just ungroup it like this. So as you can see, it generates 2 different characteristics for this dimension, and the rest of the balloons they are renumbering itself like this. So if I want to go to the back position, I can just group it with the shared balloon. So that's how the software is very smart to understand the group, how we can get the information about the grouping, right? So now it's time to apply some key dimension, dimensions. So basically I see I want to get this 13 and 14 number with as a key dimension. So let me just select it over here. So as you can see, the balloon shape is it become different. So basically this information we can get separately in a different column in a report according to our requirement. So let me do the same thing for the 14 number. So that's how we can apply, right? So here also I want to give some operations and the measurement technique, how I measure it or how the feature is produced in this part. So one of the good ways is to select any characteristics over here, and by using these properties I can add here operations such as let me add here a milling operation, and let me also add here the digital caliper to measure this dimension. So that's how we can apply these values and we can get in the report. If you want to change the vendor, as I mentioned before, we can add it over here, also delete it from here. We can also do the same thing for the operations as well as for the inspection method for the inspecting these kind of dimensions. We can add it like this. Okay, so if you want to also add more these characteristics, so let me select here multi-characteristic by just holding the control key, and let me also select this one, and that's how I can apply this value directly over here, and just let me rebuild it over here. So that's how we can apply this all kind of information by selecting the particular balloons over here, right? So now let me add here another feature. So let me open this part first. So basically I'm going to add here some fillet feature by adding some value. So I want to select these 2 edges and just let me save this part. So what if I added some feature after collecting this data? So here let me add some dimensions to this feature like this, and this is basically 2 times. So let me write down here 2 times. So when I update the project, the software is smart to understand there could be something changed, right? So if you want to accept this annotation, so we can accept this separately as well as we can accept all of the required characteristics. So that's how it rearranged the balloons like this in a clockwise directions. So as we have seen, it is very easy to manipulate the data. Also it is very easy to ordering the balloons by making some changes. Also we can update the data after making some changes, just I have shown to add some fillet features as in a previous slide. So it's time to export the data. So basically in this application we can export the data with different formats such as a PDF, Excel, e-drawings, as well as the inspection project. So this inspection project basically we can open in the separately in a standalone application of SolidWorks Inspection. So this time just let me export it with the e-drawings. So e-drawing is a highly compressed format in which the viewer can view, print, as well as mark up the design. So that's how they can solve the issues by adding some markup there. So let me open this in a separate window. So basically this software is free for the Windows as well as for the MacBook, so you can download it and you can just use it like this. So here I can change the display style of the views. I can zoom out some area to inspect. Let me do the same thing here again. Okay, so that's how we can inspect some areas. Also we can rotate this view to inspect the part from every side in a 3D. So let's get back again to the home position. This view looks bare to me, so I think there is something missing over here. So if I want to highlight this area, I can just simply highlight it like this. And if I want to write some issues over here, so I can just write down here note such as reference dimension required. So I can save this e-drawing with this markup, as well as I can separately save this markup to the proper place where the designer can get the access to that. So let me write down here markup and just let me save it like this. And as a designer I can get this markup by inserting it over here. So let me just insert it over here, and that's how I can see what kind of issue need to be solved. So here let me just delete this from here and let me add here dimensions to them. So here basically I'm going to add dimensions as a reference dimensions to this part. So let me just keep it in a reference dimension, and now let me again update this project like this. So again it recognizes something is changed in our project. So just let me accept this value. So now it's time to export this report in Excel. So let me choose the appropriate template over here and let me save this thing with the proper name, and just let me export these values in Excel. So that's how we can get well organized report in which we can get all the information related to the component and the document and also the vendor, and also we can get the all kind of information required for the report here. So this report is in which they are already calculated with some smart functions. So let me add here some values. So if I'm going to add here 6.5, it shows me in a red color. So it shows this dimension is not within the range of this. So if you are measuring dimension by vernier caliper or another method, and if you get this value, then it would be not acceptable within this range. So now let me add here another dimension. So as you can see, it becomes green. It means this dimension is between these two range. So that's how we can recognize basically the dimension are within the range or not. And also we can get this information about the tooling for measuring as well. So as you have seen, we can export in various formats by using this application. Also we can generate the qualitative documents for the requirement. Also we can improve the product instruction by exporting the well organized report for the inspection as well. So now it's time to create the customized template for the report. So basically this saves our time a lot, because we don't need to add all kind of the different kind of rows every time, or maybe it's the columns every time to get the desired output. So this time I'm going to create here the new template. So this time let me choose some existing template over here, and here this is Excel file basically, so we can use it as an Excel file normally. So let me just add here some row, and let me add here some values whatever I want to see here. So I want to see here key dimensions. Just let me insert it over here, and let me add here some operations, how the feature are made. So just let me finish it, and let me save this with some proper name, and it is done. So that's how we can generate our own customized template basically. And if I want to export this to the Excel by using the same template which I have just created, I can just simply select it and I can just save it with the proper name, and I can get all the information required with the key dimensions as well as with the operations. So I already assigned only these characteristics. This is made by milling, so it comes here itself, and I have assigned these two values as a key dimension, so it becomes true from the false. So that's how we can customize the report according to our requirement. So as we have seen, it is very easy to create the customized template. Also we can check the values by adding and measuring manually, and we can check the values are in the range or not. So let's move further. So if we do not have any file made by SolidWorks or other 3D CAD software, or we have just an image file or PDF file. So in this case, we should use here the application, the standalone application of the SolidWorks Inspection, in which we can recognize the character directly over here. So just let me choose here any PDF file. That's how, as you can see, this is just an image file, so nothing can be recognized over here. So basically, if I want to recognize this, I can just simply collect the data by just selecting the window. So I want to get this part number over here. Just let me select this icon and just let me collect this information to there. So already it recognized itself like this. So let me do the same thing for the part number. It is there. The part region, let me write down nothing is there, and let me write down here document number with the all information over here, and also let me choose the document number as a part number, and the revision is 0. So now I also want to choose here some material. So that's how we can recognize. And I also want to add the designer or the person who is ballooning this, so it could be some engineer. So just let me choose here name of the engineer. Also let me choose the name of some quality manager or some assurance manager. So let me do the same thing again, and that's how we can collect the information. So let me show you how we can collect the data or recognize the characters for the dimensions. So here there are numbers of different tools available here for the geometric tolerances, dimensions, the welds, knots, and surface finish over here. So by just selecting it, I can just select the dimension, so it can recognize like this. As you can see, I can just select it specifically and just let me just hit it here, and it gives us value of 20, and with some tolerances as we already assigned to the standard tolerances. So here, if you want to change these tolerances, basically in this application, we can change it over here in a characteristic tool, and that's how we can change these values for the angular as well as for the linear dimensions. Let me just hit OK. So let me do the same thing for this value. So while I just select this window, it counts to 2 different characteristics. So that's how it recognized. So what if the dimension is not in a horizontal line, it is maybe in a vertical position? So just I can select it and I can just rotate it like this, and I can just recognize it like this as here. So let me do the same thing for this. This is basically basic dimension. So let me specifically select here this number, and let me check the dimensions as a basic dimensions like this. So let me do the same thing for this dimension, and this could be the reference dimension basically. So just let me hit here reference dimension. So that's how we can recognize different kind of dimensions like this. So let me choose these dimensions as well, so it can recognize all dimensions. It recognizes a subtype as a diameter. So this software is very smart. It can understand this kind of different kind of changes like this. So here let me recognize these geometric tolerances. So here I'm going to choose the position we require. We can check, specifically select here number. So it takes number like this. Let me add here this kind of symbol for the diameter, and let me add here some datums. So that's how we can recognize the geometric tolerances very quickly. Also, let me recognize this dimension with some tolerances. So in this case, I'm going to choose these dimensions like this, and it can recognize itself what kind of dimensions it is. So if it could not understand itself, so that's how there are some other tools. We can just select some basic values. Also, we can select here dimensions separately for the tolerances. So this is how we can recognize this kind of dimensions as well. And what if the dimensions is not horizontal position or vertical position? So here there is some wheel, we can just rotate it, and we can just rotate the dimensions according to our required position. So here let me choose this dimension like this, or maybe choose it again, and I can just hit like this, and it can recognize like this with some tolerances as well. So that's how we can manipulate. Also, we can get recognize this kind of characteristics from the PDF file. Also, as you can see, I choose this 6 number over here, and it counts 2 times, as you can see. So if I want to make it separately, I can just make separately with a shared balloon like this for this characteristic. So that's how we can just change the grouping of this. So as we have seen, it is very easy to collect the data from PDF and 2D files. Also, the workflow is very simple, and we can recognize the GD and T the 3D and T tolerances, as well as the cross position dimensions as well. So now it's time to manipulate the data and get the results. So as I have mentioned, the 6 number characteristic has 2 different characteristics. So that's how we can just ungroup it or group it as I shown in add-in application. So let me choose these 2 characteristics again, and let me choose this shared balloon. So that's how we can just grouping and ungrouping it. Also, if you already have some revision available here, so we can basically compare 2 different drawings by using this application. So let me select here another PDF file over here, and that's how basically we can check the changes done already in this different revisions. So already you can see with some red and green lights, green lines, so you can recognize what kind of changes already done with the revision, and we can just simply replace it with the new revision. So that's how we can update our drawing according to our requirement. Also, let me show you another very good thing by using this software. So let me just close this project first. So here basically we can use the CMM data, which is called the coordinate measurement machine, the data collected by the machine. So that data we can also recognize for our requirements. So let me open here another project. So here I'm going to choose this project over here, and the measurement for this project I have already gained this value from the CM machine for the coordination measuring machine. So let me add here file of the data which I collected from the machine. So let me choose it from here, and I already have this file available here. So this all kind of dimensions I have collected from the machine directly. So if I want to apply this all the values to these characteristics, so we can simply assign this value to the item, the types, the nominal values, as well as plus minus tolerances. So this time I want to apply to this 4 different type of characteristic, and that's how we can get the idea about the range of this kind of measured dimension. So as you can see, the all dimensions here, highlighted with the green color, it means that these dimensions are acceptable for the production. So that's how we can compare it like this. So if we also measure these values by using some manual method, so that's how we can also compare it, and also we can get the exact output like this. So in this case, I'm going to use this value because this I have created by using some manual method. Let me do the same thing for this one. So this could be also acceptable, and this time let me do the same thing. So this is at the end of the limit. So here, as you can see, that could be acceptable or not acceptable. Also, let me add here some another value which comes with the red. So it becomes blue. It's become red from the green. So the machine data is with a green color, and the manual method comes with the 0.8 value with the red, which is the red color. So these dimensions shows it could not be acceptable anytime. So that's how we can compare this data by using CMM methods. And also here we can publish this all kind of information to different kind of XML files and this kind of stuff, as you can see here. So we can collect this kind of data basically for different kind of requirement for the quality programs. So as we have seen, we can grouping the data according to our requirement. We can compare and replace drawings. Also we can import the CMM data and we can compare them with the manual method, and also we can publish the data according to our requirement. So let's move further. So here in this application, we can not only create the inspection for the 2D documents only, but also it is supported for the 3D file. So let me just close this project first. So let me open here, add here 3D file over here. So let me select this 3D file, and that's how we can open 3D file here directly like this. So let me just zoom out over here. Let me change the background so you can see better. So that's how we can open the 3D file. And if you want to add some, if you want to see some dimensions in 3D, so that's how we can recognize like this. So basically this 3D design could be very useful for paperless design. So that's how we can also get this information by using some embedded tool in a SolidWorks. So if I want to recognize this kind of characteristics, so let me just assign it by just selecting it. So let me just select this one, let me select this one, this one, this one, as well as let me choose this one. So that's how we can recognize the characteristics, and we can collect the data as we have collected in a 2D file. So that's how we can collect this data for the 3D file as well. So as you have seen, the 2D and 3D CAD files supported in our software. Also we can generate the paperless design for the production. Also sometimes it could be possible the type of the language comes with a very some unusual characters. So sometimes it is required to be recognize this kind of character first. So also in this software we can recognize this kind of languages by using different methods. So let me just close this project, and let me just open new project by selecting another PDF file. So here I'm going to choose this PDF file, and it has a different kind of shape of these characters. So if I want to recognize this character, I can just simply select it over here, and I can just make it recognize. So this it already understand 0, so this looks fine to me. And just let me choose this all row by selecting this multi characters. So let me select this all row, so it recognizes all kind of characters like this. So some characters could be specifically recognized, so let me select it over here. Let me choose here another characteristics, and let me choose this one as well. So that's how we can recognize these kind of symbols, right? For this A to Z, I can just select this multi-row, and let me just recognize this A first, so it already recognized. Let me do the same thing for the rest. So that's how it can recognize the different kind of languages over here. So as I have already recognized this kind of language, so let me write down here, choose here some note, and if I want to recognize these characters, so that's how I can just select it, and it can already recognize this is the through hole. So that's how, if you have different kind of the style of the language, we can recognize by using the inspection method. So it is very easy to recognize the data in the languages, and it supports the many different languages as well. So it is our end of the session. So anybody, if you have any question, so please you can tell me. I can try to solve the questions at my best. Or if you are not able to reach to me, you can write down the note in a comment, so I can just solve out your question, and I can write down the answer for it. Do you have any question? Nobody. Thank you for this is so end of this session. I hope all you are doing well, and have a good rest of the day. Thank you. Bye.